Okay, so let's expand that idea beyond the tangent into the sine and the cosine as well as the tangent. So I'm going to kind of go through all of those in this particular video, and we'll talk a little bit about that idea. So the first thing to know is when you're dealing with trigonometric ratios, there are three trig ratios. The first one is the sine. The second one is the cosine, and the last one is the tangent. And as it turns out, no matter what angle, I'm using the Greek letter theta. I just kind of like that way personally myself, but we could say sine of A or the cosine of B. It's okay. But the sine of any angle is always defined as the opposite side divided by the hypotenuse. The cosine is defined by the adjacent side over its hypotenuse, and the tangent is the opposite over the adjacent, which we studied for a few days. Now, the thing is that's a difficult thing for many, many students to remember how to do. So we have little mnemonic devices like PEMDAS or Roy G. Biv that we use in life. And so what we're going to do is say SOHCAHTOA, and that's a really helpful little mnemonic device, just like PEMDAS. SOHCAHTOA is sine is opposite over hypotenuse, ka is adjacent over hypotenuse, and the tangent, SOHCAHTOA, the tangent TOA is opposite over adjacent. But again, that gets people like they're stuck. They don't know how to spell that because so doesn't that H sounds silent. The ka, the H is silent. So people kind of have like different ways that they will remember it, but you could say some old hippie caught another hippie. Some old hippie, SOH, caught another hippie tripping on acid. Kind of a silly little statement, but it's a good way to do it. So TOA, this is asking me for a tangent. The tangent TOA is opposite over adjacent. That's 36 over 27. We should divide by 9 and get 4/3. The sine, some old hippie, sine A is opposite over hypotenuse. So the sine opposite over hypotenuse, again, I could divide by 4 and I would get 3/5. The cosine, A over H, ka, so ka, toa. The cosine is the adjacent, that's 30 over hypotenuse, which is 50, which we could reduce to 3/5. Tangent. Tangent is opposite. Oh, we're looking from here. Opposite over adjacent. The opposite is 20. The adjacent, SOHCAHTOA. That's 20 over 21. The sine of C, now you got to keep in mind, you got to look at where we're looking. The sine, some old hippie. Sine is opposite over hypotenuse. That's 8 over 10. Opposite over hypotenuse. That's 4/5. Let's see, back to a tangent. TOA. Just got to keep practicing. That's 30 far away over 40. That's 3/4. And we could practice that a few times and just keep practicing that idea. This one, I'm going to look for the adjacent over the hypotenuse. That would be the close one, 35 over 37. And I think you could probably get the idea. Now, with that in mind, sometimes we could use this to find a missing angle. So when I look at, I'm going to skip over this problem because we did that in the last video, but I like this one right here. Let's imagine I was looking for this. Well, this is a hypotenuse. This is the side that is adjacent. And so the one in SOHCAHTOA that uses an adjacent and a hypotenuse is the cosine. So I'm going to ask my calculator to take the cosine of 49. Its definition is adjacent on top, hypotenuse is on the bottom. So we're going to do exactly what we did on the last video, except we're just going to use the cosine button instead of the tangent button. And I got 0.656 is x over 17. And then if I multiplied both sides by 17, let's multiply both sides by 17. These would cancel. X would be 11.153. Done. Now, this one right here, let's see. If I'm looking for number 15, I'm specifically kind of bounce around a little bit. Number 15 would be that the sine of 21. And I picked the sine because this one is opposite or far away. And this one is hypotenuse. It's far away over hypotenuse. So the opposite of 17, the hypotenuse is x. Now, this is one of those problems we talked about that's a little unfortunate. Sometimes the variable's in the bottom. But if that happens, we're going to multiply both sides by x. And so x is being multiplied by a sign. And so the last thing is we're just going to divide. Now, some people will choose to turn it into a decimal first and divide by the decimal that way. This is actually a little bit safer, that x is just 17 divided by the sign of 21. And I got it. That's 47.437. Now, I want to mess this up a little bit, and I'd like to actually move the x's position to here. And let's just see, from that one, the 20 is far away. That makes it opposite. The x is the hypotenuse. So let's see, which one of these uses an opposite and a hypotenuse? Well, it can't be the tangent because it doesn't have one, but it has to be the sine. So again, it's not super difficult to figure out those ratios, and that's very much like the last problem I did. So I'm going to divide both sides by the sine of 48. So I just need to take the 20 right here, and this is being multiplied. So I'm going to divide by the sine of 48, and I found that the missing side is 26.912. Okay? Now, we can carry that a little bit further because just like before, we can not only use the angle to get the sides, we can actually get the sides to get the angles. So if this is my unknown angle right here, I'm going to call this A. This one is close, that's adjacent. This is across from the 90, so it makes it the hypotenuse. And the trig ratio, so ka, toa, the one that uses an adjacent and a hypotenuse is right here. That's adjacent and hypotenuse. So the cosine of some angle, I don't know what it is adjacent over hypotenuse. And if I want to find that angle, I hit second cosine, and I hit 24 over 25, and it says that my angle is 16.3 degrees. And we pretty typically will round it to the nearest whole degree or a tenth of a degree. From this one, this is far away and this is hypotenuse. So the one that uses opposite and hypotenuse is a sine. So I could say that the sine of some angle A is 14 over 53. So once we set it up, we're good to go. Inverse sine of 14 over 53. You just have to pay attention to which trig ratio you have. And I just found the measure of angle A is 15.3 degrees. This direction actually says to the nearest degree, so we could have just said 15 degrees, but we could do all sorts of problems. The biggest thing is you need to think through SOHCAHTOA to think about which ratio you have. And last but not least, if something happened which is weird, I'm going to make a different one. Let's say it was a 3, 4, 5, and you're in a position where you have more than one thing. You could say that the sine is 4/5, or you could say that the tangent was 4/3. All of these are true statements. I could say the cosine of A is 3/5 because it's adjacent over hypotenuse. Well, the interesting thing is the inverse sine of 4/5 would tell me that the angle is 53 degrees. But if I tried the inverse tangent instead, 4/3, what do you know? I got exactly the same answer. Or if I did the inverse cosine of 3/5, I got the same answer. That's the cool part about it, is if you have more than one, you can do whichever one feels the easiest for you to understand, and they should all agree and have the same answer. Okay, I will see you back in class. Hopefully that was helpful. Goodbye. Have a good one.